Welcome to the deep dive. Today, we're looking at JavaScript testing fundamentals. And not just because, it's on the JSDev exam.
No.
So it is, about 7%.
Right. We're focusing here because good testing, it's really, I think, the core of professional development. It forces you into better design.
Exactly, forces that decoupling. So our mission today gets you up to speed fast on the essentials of unit testing. We'll be pulling ideas mostly from, frameworks you likely use, like Jest, especially with LWCs.
Let's start with the basics, the structure.
Okay, so a unit test. Conceptually, it's simple, right? Just verifying one small piece of code works, like a single function.
That's the idea. One function, one method, working exactly like you expect. But you don't usually write just one. You group them.
Right. You need some organization. If the unit test is the individual soldier, what's the squad?
That's your test suite. In Jest terms, that's your describe block. It's more than just a folder, though. It groups related tests, sure, but it also lets you manage shared setup for all the individual test cases inside.
And those cases are the test, or it functions, each one checking a single thing.
Precisely. One specific scenario per test.
And inside that test, the absolute core, the moment of truth.
Oh, that has to be the assertion. Usually an expect call. That's where you state your claim. I expect this thing to be...
Simple enough, but the whole system hinges on one really critical principle, doesn't it?
It does. Isolation. Your unit test must be self-contained. Completely.
No real databases, no hitting live APIs, nothing external that could change or fail, right? Makes sense. But what if the function's job is to call an external service? How do you test that in isolation?
Great question. That's the perfect setup for mocking. A mock is basically a fake, a stand-in for that external dependency you mentioned.
A fake. Okay, so it pretends to be the real thing.
Exactly. And it does two vital jobs. First, control behavior. You tell the mock exactly what to return when it's called, so you always get a predictable result for your test.
Okay, so predictable results makes sense. What's the second job?
The second job is verification, sometimes called spying. You're not just checking the final output of your function anymore. You're checking if that mock, that dependency, was actually called.
Ah, so you're checking the interaction.
Yes. How many times was it called? And crucially, what arguments did your code pass to it? That verification is key.
So, like in the example where a module saves something, you don't just check the save worked.
Right. You'd check that, say, an internal log activity function the mock was called precisely once. You'd use something like to been called times 1.
Okay, I see. And because you're looking inside the function's process, controlling its dependencies, verifying those internal calls, that makes mocking a white box technique, yeah?
Definitely. You're testing based on knowledge of the internal structure. That's white box.
That's a really important connection for you, the listener, to make. Mocking is white box. Okay, moving on. Beyond structure and isolation, what's the biggest mistake people make? I feel like it's testing only the easy stuff.
Oh, absolutely. The happy path trap, you test adding 2 plus 2, it works, you move on. That gives you, false confidence.
Because real-world data isn't always perfect.
Never. Effective tests have to cover edge cases and negative testing. What happens with null or undefined, empty strings, empty arrays, wrong data types. You need to anticipate failure.
And anticipate it reliably.
Yeah.
The tests need to be repeatable, right? If a test passes once but fails later just because another test ran first, that's useless.
Totally useless. That's why good tests use setup and teardown logic. Things like before each and after each to reset the state, clean up mocks, remove any side effects. Each test needs to run in a clean, predictable environment.
Okay, so let's wrap this part up. The key takeaways for you listening are what? 3 main things.
I'd say 3. First, get the terminology down. Pat suite, case, assertion, unit, white box, black box. Second, understand isolation and how mocking achieves it. Third, master verification, not just checking the result, but verifying those crucial interactions with dependencies.
Terminology, isolation via mocks, and verification.
Got it. And mastering these isn't just about exams. It's about building code you can actually trust, deploying with confidence.
Which, leads naturally to the next topic. If good testing means thinking about how things can fail,
then you need to know how to handle those failures when they inevitably happen, right?
Exactly. So next time, we'll shift gears slightly. We're going server-side, Node.js, NPM, focusing on the best practices for debugging and error handling in that world.
How do you gracefully manage the problems you plan for? Something for you to think about as you start applying these testing ideas.